So today's topic is transportation problem as a special case in a linear problem. This is the second method which is used to solve the transportation problem in linear program. The second method is a least cost method. In this case, what we do? In this method, we choose the least cost cell for the allocation, and the remaining process is similar to the northwest corner. So solving this problem, transportation problem, we learn we learn about the least cost method. So this is the example. Find the least cost method for the following transportation. Here's the given transportation. There are S1, S2, S3. There are 3 sessions, and D1, D2, D3, D4 are 4 destination. The supply is given 7, 9, 18. The demands are 5, 8, 7, 9. There are total 9, 1, 2, 3, 4, 5, 6, 7. There are the total 12 cells present in this question. So we first of all, to solve any problem in TP, we check this is the balance TP or not. So balance TP means the demand is must be equal to the value of supply. Here the number of demand and the number of the supply is totally equal. So this is the balance TP. So now we make the allocation here. Now we solve this question. So first we check in between the 12 cells which is the minimum cost. So here the minimum cost in this table is 8. So we make the first allocation here. So the demand of this cell is 8 and the supply is 8, and so we make the allocation of minimum value, that is 8. So we make the allocation of 8. So now this 8 is get cancelled and now it remains the 0 cell. So we cut down these two cells and subtract this 8 from the 18. So now it remains the 10. So now these 3 cells are get cancelled. 1, 2, 3 cells are get cancelled. Now we choose the least cost between these 9 cells. The least cost between this 9 cell is a 10. So now we make the next allocation here. So we make the allocation of which is less between the supply and demand. So here the supply is 7, the demand is 14. So between 7 and 14 the 7 is less. So we make the allocation of 7 here. Now this 7 gets subtracted and remains the 0 here, and in this demand value we subtract the 7 from the 14. Now it's remain the 7. There is no other allocation here, supply is finished, and so we make this line cancel this row. So now we check between this 6 cell which is the minimum cost. Between the 6 cell the 20 is the minimum cost. So we make the next allocation here, which we make the allocation of 7 here. So it's remain the 0 here. Subtract 7 from the 10, this remains 3 here. So there is no after this there is no other allocation. So after this we check the minimum value between this 1, 2, 3, 4, 5 cell. This is the 40. So we make the next allocation around this cell. So the next allocation we can make here, the max allocation is 7, the demand is 7 and supply is 9. So we make the allocation of 7. Now complete this allocation. So we get here 0. So we cut down this cell and subtract 7 from this 9. So it remains 2. Now we check this cell 60, 70, 40. The minimum cost between this remaining cell is 40. So we make the next allocation here. So here the demand is 5 and supply is 3. So we make the minimum allocation of the value that is supply. So we make the allocation of 3 here. Now the subtract 3 from this 5, it remains 2 here. 3 gets cancelled and only remains 0. Now there are only 2 remain cells, that is 60 and 70. Between the 60 and 70, so no, here we look at this, there is no another any demand. So we cut down this cell. Now only one cell is remain for the allocation, that is 70, and also that is minimum compared with itself. So with the next last allocation here, that is allocation of 2 in this cell, and cut down, subtract this 2 from this 2, we get here 0. Subtract that 2 from this cell, we get the 0. Find out the meaning of this cost. We find out this table. We draw this table where first column is allocation, unit cost, number of units, and cost. So first allocation we made in this table is that S1 to D4. So we write down here S1 to D4. The unit cost of this table is 10, and the number of assignment we make is 7. So multiplication of these both, it's right here, that's 10 into 7 is 70. We do this for all the cells present in this block. So we write down the all allocations, unit cost and number of units, then multiply this unit cost into the number of units, then we got this value which is cost. The addition of all this cost is the minimum value or the minimized minimization of this transportation problem. To check this is the basic feasible solution. We check this for, we put this equation, we check the allocation which I have made here, that is m plus n minus 1. Here m is the number of supply, that is 3. N is the number of destination, 4 minus 1. The total is of this is 6. So number of allocation must be equal to 6. Then it is the basic feasible solution. The number of allocation is 1 2 3 4 5 6. The number of allocation in this table are 6. So this is the basic feasible solution for this question.